Friends, today we are going to tell you the different type of casings used in compressor. That is the centrifugal compressor are manufactured with two types of casing. One is called horizontally split. This is called horizontally split. This one is called horizontally split casing, and the vertically split casing, and this is called the vertically split casing or barrel casing. The horizontally split casing is split along the rotor shaft and bolted at split line. These are rotor shaft. It can be split in the rotor shaft along the rotor shaft, and it is bolted in between the plane. Two plane. You see, this is the bolting. This is the top half of the top casing, the bottom casing. This is the top casing, and these are two casing are bolted. Hmm. And Mm, the horizontally split casing and casing generally employed either an up nozzle arrangement as illustrated in the figure or down nozzle. These are horizontally and down nozzle arrangement. This is the down nozzle arrangement. This is the up nozzle arrangement. This is the up nozzle. This is the barrel casing. Uh, Barrel casing. This is the horizontal casing. This is the down loading arrangement. This is the up loading arrangement. In horizontally split compressor, in order to in order with down nozzle, the compressor casing can be opened and rotor assembly lifted with an overhead crane without disturbing the process piping. Means suppose these the nozzles are down are bottom side, so you can open this top casing and with the head of a with the help of a overhead UOT crane, overhead crane, EOT overhead electrical overhead crane, you can remove this top casing in the top casing. The space requirement for maintenance and therefore minimal, because other if casing is at the top, so you cannot remove the top casing. You have to remove the piping first, and then you can remove the top casing. And in this particular configuration, when the nozzles are at the bottom, you can remove the top casing. You can remove the top casing, and this is the barrel type. So here the rotor will come on the from the end. So there is no question of removing any case. Barrel will be in position. Only rotor assembly will come out. So in this case also there is no need of removing the pipings. Now in the horizontally split casing, you can see that when the pressure is more, there is a chance that the process air can go outside and process air can go one stage to other side. To arrest this interstage leakage or through the parting plane, what we are doing, we are making a groove here. Use the violet color. They are the grooves, and at least 2-3 millimeter grooves are there in the parting plane. There we are using either o-ring or also seal type o-ring, and then press the top casing so that there should not be any leakages from the parting plane to outside and interstage and through the interstage also. So suitable o-ring are used to avoid arrest parting plane leakages. So this is the normally we are used to do. Other, if you don't do this group, there 100% blue matching and perfect sealing is required. That may not be possible. But if you make the group and place the o-ring, then you can arrest the leakages from casing to outside and interstage also. Interstage casing also. Interstage also. Now 500 psi at about 500 psi horizontally split casing lose their sealing capability. So the sealing, if you use o-ring also, then also it is not possible to arrest the leakage. Resulting is an increased potential for escape the process gas. But above this level, manufacturer will resort to the vertically split vertically split type or barrel type compressor. This type of casing has the rotor assembly housed in a complete cylinder. This is the cylinder. If you say this is the cylinder, this is the rotor. We are taking out the rotor assembly, assembly from the casing. rotor as well as the diffuser casing from the outside casing. Diffuser, the compressor assembly, the diffuser and rotor from the casing, or the cylinder. The rotor removal occur at the end of the compressor. From the end cover is there. From the end, we are taking out the end of the compressor by sliding the rotor assembly or and diaphragm and inner casing. This one is called inner casing also. Outside the barrel. This is the barrel. Outside the barrel. In there is parting plate leakage. There we are using some O-rings so that interstage from end cover also, the high pressure to low pressure also, there is no no air or no process gas will come. As a result, sufficient space must be available for removing the and maintain the rotor assembly. As it is the casing is not removed, only from the end cover. First you remove the end cover and then take out the rotor assembly along with the diaphragm and inner casing. So there is no question of taking the piping out. If the piping is outside, vertical upward or bottom side, so that will not be disturbed. Will not disturb. This is the advantage of barrel type casing, and apart from the sealing also. Then arrangement of casing, it is you see this is one through the compressor. You see this is a suction. This one is the discharge. Suction volume is more. That's why area is more, and gradually area is coming down. After number of stages, it is coming out. This is coming out from here. It is going to the suction again through diffuser. Then you call the vent. Then diffuser discharge channel. Then again second stage, like this. It is going enter different stages of the impeller, and then finally it is going out. So it is the straight through centrifugal compressor, centrifugal. And to when the flow requirement is very high and your head requirement is low, at that time what we are doing to reduce this compressor size, we are double entry employed, double flow arrangement. From here also it is entering, after 2-3 stages it is coming out. Here also after 2-3 stages they return. This is the outlet flange, this is the inlet flange. Here also advantage is there. This the arrangement is like this. Impeller, they are balancing to each other. They are balancing this, the high pressure to low pressure this side, here high pressure to low pressure side this side. So both are, the rotor is perfectly balanced. Though there may not be required any balancing term, but particularly in this case balancing term is required. For here low pressure, this side is high pressure, so tendency will be high pressure to low pressure. So we have to use the balancing term to balance the rotor in position. Now sometimes that gas become due to the high molecular weight, the gas temperature of the compressor become too high, so you cannot pass through in a single compressor of different stages. So due to this high temperature, improve the one can maintain reasonably discharge temperature and actually improve compression efficiency by cooling the gas part way through the compression process. So you are taking out, if temperature is very high, so the compression efficiency will lose. So you have, what we have to do, we have to take out for the suction. This is the discharge. So take out the fluid outside and then cool it, and then again enter it to the next stages, so that efficiency of the compressor will increase. And but the disadvantage is that the length of the compressor between bearing will increase. So there is a chances that it may fall, the running speed may fall above the critical speed, or in above the critical speed. So you have to be very careful so that the rotor not run at critical speed. So not run at critical speed. So you have to, operating speed should be far away from the critical speed, because due to the additional two nozzles are there. You see the additional two nozzles are provided. First, this suction nozzles, then it is coming out due to high temperature. Again, you have to cool it, and then again you have to into the two nozzles are required to be built in the outer casing. So naturally, the length of the compressor between bearing will increase, and when the length of the between bearing will increase, the critical speed will come down, and then your operating pressure, operating RPM may disturb the critical speed, may fall on the critical speed. So accordingly you have to choose the operating speed so that the critical it should not come very near to the critical speed. This is sometime one is particularly high molecular weight gases. Heat generation will be more. Heat generation will be more. So we have to during more during compression than the low molecular weight gases. So what we have at that time we may have to take the two times the gas outside, cool it, and then again put it back to the compressor, and again take it out, again cool it and again put it to the remaining stages, and finally coming out. So for to accommodate all this thing in a single compressor, the compressor length will increase, this could become a problem if too many cool points are attempted. There are two cool points are maximum feasible number of a single compressor casing. So earlier drawing we have seen the only single type single fast compression, then taking out, then cooler, then then again going inside the compressor casing, and finally coming out. But in the second stage, it is you have seen two times the fluid gas has been taken out, and then cool and intercooler, then coming put it inside, again taking out and cool it again, and again put it inside, and finally though this is the maximum two tapping is allowed, otherwise compressor length will very increase, and that will create the problem for the critical speed will operating speed and critical speed may come very close to each other and difficult for the operating range. In some process refrigeration, we have to insert refrigeration requires several pressure levels from the compressor. Several pressure, you have to take out the compressor, require several pressure levels from the compressor. The manufacturer can accomplish this either this by using the side load or side stream compressor. Side stream compressor. What is this? Now you see this is the refrigeration compressor. There are so many pressure levels are there. So you have to take out the compressor, then cooling, and again putting back, putting inside, putting back. In this arrangement, the main gas stream enter the compressor. Main gas stream enter the compressor inlet nozzle, and at the required pressure level, another gas stream enter through an intermediate inlet nozzle. This is coming, it is, you see this is the first gas is coming, then this is the discharge of the impeller, then second gas is also entering, and then both are mixing here, and then enter to the second stage impeller, and then from second stage impeller they are and another second outlet of second stage impeller, then again another stream of gases are mixing with them, and then finally it's going to the third impeller, and finally it is coming out. So you have to introduce intermittently due to the requirement of the process requirement, particularly during particularly for refrigeration compressor, insertion of the gases is required. So when the gases are put inside this compressor barrel, you see separate diffuser from the in place of diffuser we are putting this gas here. You see this is the suction of the first stage impeller, it is going out. This is the diffuser, This is the return bin. This is the channels, return channels, and here return channels, and it can go to the second stage. But before going to the second stage, what we are doing, we are from the side, from the outside, we are taking another one gases of same pressure and then mixing it here and then put it into the second stage. And from second stage, you see this is the diffuser. This is the return channel. This is the this is the return bend. Bend. This is the return channel. This is the return channel, and there what we are doing, we are through another gases we are putting into the return channel, and not for the different not here it is mixing in the return channel. Here we are mixing after the return channel, after the return channel. So here mixing will be more efficient. Here mixing will not be more efficient because it is fluid is coming down return coming down to coming downwards to put to go into the next stage. Here what we are doing, inserting other gases of same pressure, of course, then through the channel inside, to the channel. So here mixing will be turbulence will be there, but here proper mixing will be there. You see here proper mixing will be there. Here proper mixing will be there. This is a side load. You see from here side load. Here it is coming out, here it is mixing, then it is going arming up, then it is going inside, then where here you see in particular the region, it is inside, it is mixing inside the return channel. Here it is mixing after return channel, it is return channel after return channel. So here the disadvantage is you need more space, here you need less space. So but here mixing will be some turbulence, mixing will not be proper, here mixing will be proper. So like this we have to take decision how if you proper mixing is required, and you have to remove some intermediate diffuser, put the gases fresh gases and mix with in the after the return channel. Mixing will be proper, but length of the compressor barrel, length of the length between the shaft between the bearing will increase. But if you put the fresh process gear in the return channel, then your length of the casing will be less and length of the between bearing will also be less, but there is some advantage and disadvantage are there that I have clearly mentioned. This is the this is the compressor, LP compressor. This is the LP compressor. This is the barrel type compressor. Barrel type compressor. This is also barrel type compressor. For easy maintenance, what we are doing, this is the turbine. You see both the sides of the turbine, both sides of the turbine, we are coupled with the compressor. So this is the barrel type compressor. So vertical pipelines are coming vertically as well as the sidewise also. It is removed to sidewise also entry is there, but we should not have any problem because we have to remove the end cover to take this barrel out, inner barrel outside. So there is sufficient space is there horizontally. There is no need of taking out the outer casing or piping. Similarly, from this side space is available, so you can take out the HP casing. There is no need of taking outer casing, inner casing and barrel can be taking out without disturbing the process piping and outer casing. So you need not do the alignment checking and others. Turbine also will remain in place, and casing also that compressor casing also so as the compressor casing is not removing, outer casing is not removing, so there is no need of doing any alignment check. There need alignment. There is no need of doing any alignment. You can check the alignment, but there is no need of doing the fresh alignment. But you are taking this casing outside, outer casing outside, then you have to do the alignment. So this is the advantage of this type of arrangement. We are keeping turbine at the middle, and both sides of the turbine it is coupled with LP casing and HP casing. The advantage is that from the end cover, barrel type compressor, end cover you can taking out the inner casing and the rotor assembly outside by sliding. Similarly, HP casing also, that will help in maintenance easy. You see, this is also our CO2 compressor. You see here the motor is there in between, both sides of the motor. This is HP, this is LP. So and outside piping are there. So you need not this end cover. If you remove this end cover, and there is no need of taking out the outer casing, no need of taking the taking this piping. Only simply inner casing and rotor assembly can be taken out from this side. Inner casing and anarchical rotor assembly of HP also can be taken out this side. This is the advantage of this arrangement. This is a 3D piping. They are nowadays you can instead of isometric you can see the 3D piping layout. So you can when 3D is available you can see very well where your maintenance point of view, where your platform is required, where hanger support is required, expansion etc. You can see very well. It was not very easy when you are simply seeing the isometric, but in 3D nowadays 3D available, 3D piping layout is available. With this you can very well judge taking decision where to put the platform, where to put the support etc. So friends, I have discussed the different type of casing, the advantage, hmm, and now once through the turbo compressor, because the when you are the compressor dealing with high molecular weight, the intermediate temperature of the case fluid will be too high, so you cannot compress it further. Your efficiency will lose. So you have to take out the fluid from the fluid gas from the outside of the casing, cool it through interstage cooler, then put it again, and that's why your compressor efficiency will increase. But the one disadvantage is that your length between casing length as well as the distance between the bearing end of the rotor assembly will high. When the rotor distance between the bearing position is high, then there is a chance the critical speed will be inside the above below the operating speed. That is and you have to take care of the critical speed so that your running RPM should not fall on the of any stage, should not fall on the critical speed. That is the only disadvantage. And side stream also entry is there. So if you want to put the some process gas inside from outside, if you want to mix, so it is better mixing will be there. When you are mixing it after that return channel, the space is available for proper mixing. But there the same problem is there. The length between the bearing, length between the of the rotor between the bearing will increase. But instead of the if you put the quantity is less, normally 10% of the inlet quantity, then you can push this gas to the return channel. The disadvantage will be that the mixing will not be the proper, but your length between the bearing, length of the sub between the bearing will be less. So I think I have, if you go through the slide, your concept will be clear, and your answer also you can prepare for the reply for the interview questions. If you have still any doubt, you can ask me.